Factor by GCF, or greatest common factor. I need to first put in standard form. So is it in standard form? And this is not, so I need to write it in standard form. So the biggest thing here is the x cubed. So the negative 12 is in front of the x cubed. After that comes the 4x, it's a positive 4x. So now it is in standard form. So I now need to find out, well, what is my GCF? We have two rules. One is for the numbers, the other is for the variables. For the numbers, I need to look at 12 and 4 and think about what can I divide evenly into 12 and 4? Well, they're both even, so I'm thinking about 2, but I'm going to try a larger number than 2. Let's try 4. Turns out that 4 works. So that's for the numbers. We also need to remember that if it leaves with a negative, it belongs to my GCF. So it's a negative 4. Now I'm going to look at my variables. Do all of my terms have the same letter? Yes. So that letter belongs to my GCF. And I'm going to pick the smallest amount of x's that are common amongst them all. So here I have 3, like x cubes. Here I have just 1. There's the invisible 1 there. So it's just negative 4x. So I know my answer is going to be my GCF and then parentheses, whatever is left over. In this case, there turns out to be 2 blanks because there were 2 blanks in the beginning. It's a binomial. So my GCF is negative 4x's. And what I'm going to do is I'm going to divide by negative 4x for both. So negative 12 divided by negative 4 is 3. This should always be positive. And then I have x cubed over x. So let's recall from previous units, x cubed over x. I'm really subtracting. So this is invisible 1. x3 over x1 becomes x2. And then 4 divided by negative 4 is negative 1. And then x over x is no x's. And so my answer becomes negative 4x parentheses 3x squared minus 1. Now, how can I be sure that I'm right? Do this if you have a whole lot of time at the end of your test. You can just simply distribute. Negative 4 times 3 is negative 12. X times x squared is x cubed. Negative 4 times negative 1 is positive 4. X times no x's is x. So does that match? Yeah, so I'm a happy camper. Let's try the second one. Now this one, considerably different. There's x's and y's and larger numbers. So I need to, again, think about same things. Is it in standard form? Well, standard form amongst many variables is you look at the variables together in the same terms and you add them up. So this is degree 4, right? 3 plus 1. Degree 3, right? 2 plus 1. And degree 2, 1 plus 1. So it is in standard form. So now I need to find my GCF. My GCF in this case is 12, 36, and 18. I need to think about numbers that divide evenly into all of them. So they're even. I'm thinking about 2, but much larger than 2, hopefully. I look at 4. Well, 18, I can't divide 4 into 18, so that doesn't work. Check 3. 3 does work, so if 2 and 3 works, well, so does 6. So far, I'm kind of checking. 2 works, 3 works. 2 times 3 is 6, so 6 must work. So now I'm looking for a multiple of 6. Does 12 work? Well, no, 12 doesn't go into 18. What about, does 18 work? Well, no, 18 is bigger than what I'm given, so 6 must be it. So it's it leads with a positive, so it's a positive 6. Then I look for letters they have in common. All these have an x, and all of them have a y, so I pick the smallest. The smallest is this x over here, and the smallest is this y over here, so it's just x, y. So now I'm going to set up my answer, 6xy blank, 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 and I'm going to do some division. So I'm going to pause because I'm running out of time, but I'm going to divide each thing by 6xy and get my answer. For the first time, I get 2x squared, pause again. Then I get 6x, pause again, work below, minus 3, and I get my answer. GCF, then polynomial.